Greetings, Physics 109 students. I'm making this video here to help you out with your units. What are we on here? I guess 5 homework. I'm sorry, Unit 6 homework. So let's see. A person observed 6 water waves hit the pier at South Haven every 24 seconds. What is the period of each wave? So the period is the time per wave. So here we got 24 seconds and 6 waves, right? So I'll let you know this. Think about if I took 6 over 24, what would the units be? 6 waves divided by 24 seconds. Think about the units. Versus if I took 24 seconds and divided by 6 waves. And then one of those numbers will have units of seconds per wave, and that's what the period is, the time to complete a cycle or to complete a wave. Okay, frequency is the number of waves per second. So again, think about which ratio. If I take 6 waves and divide by 24 seconds, or if I take 24 seconds and divide by 6 waves, which one of those is going to give me a number of waves per second? I'll just say that. Okay, for the next part, what would you expect the wave speed of the if the person observes that the waves are 6 meters apart? So for all wave phenomenon, the velocity of the wave is equal to frequency times the wavelength. Now the wavelength is usually denoted with this as the Greek letter lambda here. I know Greek letters kind of make everything seem complicated, but that's the wavelength. So when it says, what would you expect the speed to be, that's talking about this. And once you have the frequency from up above, and where this says the crests are 6 meters apart, so these waves, we're talking about like from here to here, that is the wavelength. So that should get you through number 2. Let's talk about through number 1. And while I'm right here, we'll talk about number 2. Let's see, a given sound wave has a frequency of 4,500 hertz. Look up the speed of sound, and I meant that to be at room temperature, by the way. It varies a little bit with temperature, but I had meant that at about room temperature. Calculate the wavelength of the sound. So again, velocity of all waves is equal to frequency times the wavelength. So you're going to look up the speed of sound, and I'll give you a clue. That's a number between 300 and 400 meters per second, but I won't tell you which. I'm going to let you look that up. The frequency is given in the problem, and then this right here, this is the wavelength. And I think what I'll do here is, because these are kind of short, I guess I'll do one more here. Actually, no, I'll do the whole page, 3 and 4. All right, so a person fires a gun, and the sound gets to the target after 1.5 seconds. So what I mean by that is like the sound gets from the gun to the target in 1.5 seconds. So how far away was the shooter? All right, so for this is actually just a speed is equal to distance over time. And for the speed, look up the speed of sound. And again, I'll let you know that's going to be a number right around, a little bit more than 300 meters per second you should be finding. And then the time is given. You can calculate a distance from that. And then number 4, virtually the same thing. Look up the speed of sound. You've got a delta t here. You should be able to calculate a distance from that. So I'm going to call that good for this first group of problems. I hope that this helps. Have a great day.